All right, so fill in. There's 3 blanks here. You've been writing these, but you didn't really understand why you were doing that. So today this might help get you where you need to be. All right, so at the top, though, it says, note, the derivatives of the 6 inverse trigonometric functions fall into 3 pairs. In each pair, the derivative of one function is the negative of the other. So then what's very, very interesting is if I have the derivative of arc sine is 1 over the square root of 1 minus x squared, then if I integrate it, then the integral of 1 over the square root of 1 minus x squared is equal to arc sine x, okay? So then what I have here, and so then if I wanted arc cosecant, arc cotangent, and arc cosine, they're just going to be negatives, okay? So we're only going to look at these 3. So here's the deal. U is some kind of differentiable function of x. If it is just x, that's terrific. But sometimes it can be 2x, or x squared, or 9x squared. And so then we're going to be doing with integrals, we have to do a u substitution. In derivatives, we did the chain rule, okay? So you're going to have to look at this or keep your goldenrod paper as we flip. Does everybody have this so far? All right, this is really not that bad, but it's like having to, keep looking till you get them down. So look at letter A. I want to integrate dx over the square root of 4 minus x squared. So here's what I strongly recommend that you do. A is 2 and u is the x. So we're going to rewrite this now. And if you, on this one, I'm not going to change it to the u because it is just the x. But out of the 3, 1, 2, or 3, is this arc sine, arc tan, or arc secant? Which format is it? It's arc sine. So this is going to be arc sine, the u is x, and what's a here? 2. So this one is just arc sine x over 2 plus c. All right, letter B. I have dx, integral of dx over 2 plus 9x squared. Well, here's the deal. Out of the 3, which one does it look like we might be able to use? 2, the arctan. The problem is 2 is not something squared. If a squared has to be 2, then our a is the square root of 2. Do you get it? Because it's a squared plus u squared. So our a in this case is actually the square root of 2. Now, what is u? U is not 9x squared. It's 3x, right? Well, the problem is I don't have, when I go to do the du, that's 3dx. I don't have a 3dx up here. So I'm going to have to do the u substitution and watch what's going to happen. I'm going to get 1/3 the integral du. I'm going to have my square root of 2 squared plus my 3x squared. Or I can call it u, I guess. We can temporarily call that u. In this case, I will, okay? So that's u squared. So now, if I look, this is definitely number 2 choice. It's not a big deal. I've got my 1/3. It's just a constant, but number 2 says 1 over a. So that's 1 over the square root of 2, arctangent, and it says u over a. Well, u is 3x, and a is the square root of 2. So all I'm really doing is figuring out how to plug everything in, okay? So we're going to tidy this up and say that's 1 over 3 square root 2, arctan, and we're not rationalizing, okay? This is hard enough. We don't need to worry about rationalizing. So that'll be my final answer. All right, let's look at letter C. I have the integral of dx over x square root 4x squared minus 9. Can you see that this looks like number 3? Okay, it looks like the arcsecant. So here's the deal. I'm going to first rewrite this as the integral of dx over x times the square root. That's 2x squared minus 3 squared. So u is 2x, so du is 2 dx, so I'm going to need a 1/2, and a is 3. Now we have a problem here, so let's kind of work this a moment. And instead of a, I'm going to leave my 3. But what about this x? That isn't just u, is it? It's u divided by 2. You guys see why? If this is x and u equals 2x, I'm going to have to replace this x. Now, when you have a divided by a fraction, that's going to end up flipping to the top, isn't it? And it's going to cancel the 2 here. So then this is going to end up being the integral of du over u square root u squared minus 3 squared. Okay, if you divide by u over 2, that's like multiplying by 2 over u. So the u stays down there, but the 2's cancel. Now I can see very clearly that this is like number 3. It's 1 over a, so that's 1 over 3. Arcsecant, absolute value of u, that's the absolute value of 2x over a, so that's 3, plus c. So it just takes a little bit of practice getting the hang of it. All right, let's try example 2. Find the integral of dx over the square root of e to the 2x minus 1. All right, well, a would be 1, and u is actually e to the x. But if I do du, that's e to the x dx, and I don't have an extra e to the x somewhere. But watch this. This ends up being really cool. If I divide by the e to the x, 1 over, this is actually 1 over u, isn't it? Okay, this is some pretty fancy work, okay? So, take your time with this. Okay, because this is going to end up being u squared minus 1 squared. I want that. But when I do the derivative of u, the derivative of e to the x is e to the x. And there's no extra e to the x on the outside. So you got to think, what can I do? If I divide by e to the x, 1 over e to the x, you can't have an x with a du, okay? That doesn't work. So you've got to come back up here. U is e to the x. That's 1 over u du. So watch what we're going to do. I'm going to replace dx with 1 over u, and I've got my du. This is the square root of u squared minus 1 squared. And I want you to look in the box at number 1. You cannot just switch the order. Let me say this again. In the box number 1, when you have the square root of a squared minus u squared, it cannot be u squared minus a squared. Like, that order matters. So when I did this, do you see now this is number 3? Can you see that this is now the format of number 3? So it's 1 over 1 arcsecant, the absolute value of u. Well, that's the absolute value of e to the x over a, which is 1. Well, e to the x is always positive, so I don't need the absolute value symbol. 1 over 1 is 1, so I'm getting arcsecant e to the x plus c. All right, we're going to pause. All right, no, we'll do example 3, then we'll do a little bit more practice.
Wait, what happened to the 2x?
That's what I was just wondering.
What do you mean the 2x?
It's e to the 2x in the top.
Yeah, I know, because, okay, if I take e to the x and I square it, that's e to the 2x.
Yeah, but like,
So it's right here.
okay.
I let u equal e to the x because I wanted u squared. Does that make sense? Okay. Okay, let's do example 3, then that's as far as I want to get, but I have some practice problems that this is, we've only done a few, and I need you to get a better understanding. All right, I can't do it this way because I've got an x plus 2 over the square root. I lost my dx. So watch what we're going to do with this one. We're going to break this apart because I have a sum in the numerator over one term in the denominator. So if I tried to do a u substitution with 4 minus x squared, it wouldn't work. If I tried to do what I did on one of the other ones, it just doesn't work. So this is another technique. And this is the super, super tricky part, is once we're done with this, we probably have over a dozen different ways to do integrals. And that's what's so challenging, is how do you know what to do and when to do it? All right, so here's the deal. In this first integral, I can do u is 4 minus x squared, and du is negative 2x dx. Well, I have an x dx. So I'm going to divide by the negative 2 and get negative 1/2 du equals x dx. So the first integral is it's not this arc sine, arc tangent stuff. It's just a straight u substitution. So this becomes negative 1/2 the integral of 1 over the square root of u du. And we could just do that with the power rule, okay? And we'll finish that in a moment. Over here, I'm going to pull this 2 out, and that's 1 over the square root of 2 squared minus x squared. Well, this one is the arc sine. So let me keep working over here, and so I'm doing both of them here, and if that's too much for you, do the one all the way down and then go do the other one. I can handle it, so I'm going to rewrite this one and say that's u to the negative 1/2. And then this one is can you tell that that one's the arc sine? Because it's the square root of a squared minus u squared. So that's just arc sine. It's x over 2 plus c. This 2 here is the 2 that's from the top, because it has to be just a 1 in the top. So then here I get negative 1/2. I increase the power by 1, divide by the new power. And then I'm done with the second one. So then this is negative the square root of 4 minus x squared plus 2 arc sine x over 2 plus c. All right, that's a lot.